Hello students, welcome to today's class. Today we will discuss about some applications of electric potential. Means we have to find out the electric potential due to different cases. So at first we should recapitulate the thing that the electric potential for a point charge at a distance r was given V equals to 1 by 4 pi epsilon 0 q by r, and its unit was volt. Now we have to calculate the electric potential due to a dipole at its axial point. Suppose we have to calculate the electric potential due to this dipole at its axial point at the point M, which is at a distance small r from the center of the dipole. So this distance will be r minus a, this distance will be r plus a. Now marking it AB. Now the electric potential at the point M, electric potential at M due to this plus Q charge will be, suppose VB 1 by 4 pi epsilon naught Q by R minus A. Similarly, VA due to this minus Q charge we will take 1 by 4 pi epsilon naught minus Q by R plus A. As these are two scalar quantity, so the net potential V net we will write simply, we will add VA plus VB. So we will have VA 1 by 4 pi epsilon 0 minus Q by R plus A plus 1 by 4 pi epsilon 0 Q by R minus A. And afterwards Q by 4 pi epsilon 0, if we take common, then we will have 1 by R minus A minus 1 by R plus A. So Q by 4 pi epsilon naught, here we will have R square minus A square, R plus A minus R plus A. So we will have 2AQ by 4 pi epsilon 0 R square minus A square. So 2AQ, you have remembered 2AQ is nothing but the dipole moment. So we will have P by 4 pi epsilon 0 R square minus A square. So this is the electric potential at an axial point due to the electric dipole. Now in the next case we have to find out the electric potential due to a dipole at an equatorial point. So for this we have considered an electric dipole constituted by same kind of minus q plus q charge and separated by a distance 2a, and we have to suppose find out the electric potential at the point M, which is on its equator, so which is at a distance r. Then if we draw, just join this line, this distance will be root under r square plus a square, and same will be this distance. This distance is a, this distance is a. Now the electric potential due to this minus q charge, if we consider VA, then it will be 1 by 4 pi epsilon naught minus q by root under r square plus a square. Similarly, due to this plus q charge, we can write VB equals to 1 by 4 pi epsilon naught q by root under r square plus a square. Clear? So the net potential we will have, if we just add up VA plus VB, then we will have 0. That means for a dipole, this equatorial plane is a plane where you will have electric potential 0. In the next case, we have to find out the electric potential at any point due to a dipole. For this, we have considered a dipole. Students, you know that we can find out the electric potential at any point on its axis. मतलब इस point में हम लोग इस axis के ऊपर कोई point में electric potential निकाल सकते हैं, इस equatorial plane के ऊपर भी कोई point में electric potential निकाल सकते हैं. But if we are asked to find out the electric potential at this point, then we will not be able to solve or find out the expression of electric potential. So for this we have to use this derivation. So suppose we have to find out the electric potential at the point M, then which is at a distance r from the center of the dipole. This distance is a, this is also a. Clear? Now if we just join these two lines like this, and we are just drawing a normal from here to this line, and if this angle is theta, this angle is theta, so this distance will be a cos theta. So as we have considered a is very less than r, means जो dipole separation होता है वो उसका value as because it is very small, so we can consider the distance mn. ये जो distance है, ये distance को हम लोग consider कर सकते हैं कुछ r minus a cos theta, and this distance mq. In similar way, if we draw the perpendicular over here, we can have r plus a cos theta. These are the two things which you should understand properly. So now for this minus q charge के लिए जो electric potential मिलेगा, that will be, I'm just writing as vq, it will be 1 by 4 pi epsilon naught minus q by r plus a cos theta, as because this distance mq is r plus a cos theta. And similarly vn, we will have 1 by 4 pi epsilon naught q by r minus a cos theta. So net potential we can have v net equals to vq plus vn. vq plus vn, तो इसको अगर सॉल्यूशन करेंगे 1 q by 4 pi epsilon naught कॉमन आ जाएगा, 1 by r minus a cos theta minus 1 by r plus a cos theta. Clear? So this will be the expression of this electric potential, and if we just solve it, then we will have q by 4 pi epsilon 0 2a cos theta by r square minus a square cos square theta. Again 2aq, we have the electric dipole moment p, so we will have the final expression p cos theta by 4 pi epsilon 0 r square minus a square cos square theta. So this will be the expression of the electric potential due to the dipole at any point. Students, now we have to calculate the electric potential due to a hollow charged spherical shell. ऐसे एक hollow spherical अगर charged shell अगर हम लोग के पास है, suppose the charge is given q, तो इसके लिए we have applied Gauss's theorem to find out the electric field. और इसका कुछ electric field का expression मिला था at any inside point of the cell, means suppose here or here or here, anywhere within the shell, that is 0. Clear? Electric field inside point में हम लोग को मिला था 0, as because no charge remains inside of the shell. Now we have the relation between electric field and potential, that E equals to minus dV by dr, means the negative of the potential gradient. As this is equals to 0, so dV equals to 0, or V equals to, we will have constant. That means we are integrating the both side, so we will have V equals to constant, and the value of this constant comes out to be K Q by capital R, means 1 by 4 pi epsilon naught Q by capital R. Means students, you have to remember it very carefully to solve different kinds of problems, that कोई भी हॉलो स्फीयर चार्ज स्फेरिकल शेल अगर है, उसके इनसाइड पे यहाँ पे भी जितना पोटेंशियल होगा, यहाँ पर भी उतना ही पोटेंशियल है, यहाँ पर भी उतना ही पोटेंशियल है, यहाँ पर भी उतना ही पोटेंशियल है, एंड द वैल्यू ऑफ दिस पोटेंशियल इज 1/4 pi epsilon 0 q by capital R, where capital R is the radius of the shell. Now in the next case, we have to find out the electric potential at any outside point of this shell. Suppose we have to calculate the electric potential at the point M, which is at a distance small r. That means this point is outside of the spherical shell. So in this case, we have to calculate the potential in this way, that we know the expression of the electric field from Gauss's theorem, Q by R square. ये गॉसेस थ्योरम से मिला था, कुछ पिछले वीडियोस में ये डिस्कस किया गया था. Again we are having the relation between electric field and potential is E equals to minus dV by dr. Now in this case we have to find out the potential. dV will be minus EdR. So integrating both sides we will have V minus integration EdR. The limit of the integration will be R equals to from infinity to R equals to R. As you know, the definition of the electric potential, thus that it is the work done to bring that charge, unit isolated free positive test charge, from infinity up to that point within the electric field. So if we just find out the expression of this E, 1 by 4 pi epsilon naught Q by R square dr, R to infinity integration. So in this case we will have Q by 4 pi epsilon naught, integration will be minus 1 by R, infinity to R. So we will have Q by 4 pi epsilon 0 R. This will be the expression of the electric potential at any outside point due to this spherical shell. Similarly, we can find out the electric potential due to the sphere at its surface. So surface के ऊपर कोई पॉइंट में अगर हम लोग इलेक्ट्रिक फील्ड निकालना है, so again we know the relation between the electric field and potential, that E equals to minus dV by dr, and we are having the expression of E from Gauss's theorem, that 1 by 4 pi epsilon naught Q by capital R square. So putting this value here, we will have dV equals to minus EdR, or V will be equals to minus integration EdR. Limit of integration, R will be from infinity to R will be equals to capital R. Similarly, just like the previous derivation, we can have minus Q by 4 pi epsilon naught dr by R square infinity to capital R. So minus Q by 4 pi epsilon naught minus 1 by R to infinity. So we will have Q by 4 pi epsilon 0 capital R. So this will be the expression of the electric field on the surface of the hollow spherical shell. Now we can depict this results in a graph, just like we have expressed the expressions of electric field by a graph. So here if we plot this, if this is the distance from the center and this represents the electric potential, then we have to remember that within the sphere, the electric potential was constant, means V equals to constant, and afterwards the graph of V is like this, V proportional to 1 by R. If we again draw the graph of electric field here, so here we will have center में inside point में मिला था electric field E equals to 0 और बाहर मिला था E proportional to 1 by R square. So this is one of the most important relation we should remember.